It's not often in mathematics that a completely new method is developed for solving old problems. So we're going to be having a look at this new method of solving quadratic equations today. This was developed by Dr. Po-Shen Lo. He is a professor of mathematics at Carnegie Mellon University in the United States. And he has developed a new method of solving quadratic equations. So let's have a look at a few examples and hopefully get the idea of how this works. Let's start with h squared plus 4h take 12 equals 0. To start the new method, we start by writing down what we would typically call the sum. So when we're factorizing, we want the coefficients of h to sum to 4. Now in this case, with this method, we take the negative of the coefficient of h. And I'm not going to explain why. In fact, I'm not going to explain any of the reasoning behind this method because Dr. Po-Shen Lo did such a good job of that in his video. I'll link that video in the description if you're wondering how this works. But we start off by saying the sum is the negative of the coefficient of h. Then we can say the solutions will be related to the average of this. So we take half of this number, -2, and we add u. And then the other solution is half of the sum, take u. So here are my two solutions, and then I want to solve for u. I do that by multiplying them together and saying their product is this constant term here. So if we multiply these out, we get the difference of two squares. So what we'll have is the square of this number here, this -2. So -2 squared is 4, and then we take the square of u, and this equals this product up here, -12. And then what we want to do is to solve for u, so add u squared to the right hand side, add -12 to the left, and we'd get u squared equal to 16. So therefore u equals 4. Then we go back to these expressions for the solutions up here, and we can say h is going to equal -2 plus u, so -2 plus 4, which will be 2, and -2 take u, or -2 take 4, which will be -6. And they are the solutions to this quadratic up here. Now you can go ahead and factorize this and check this yourself. If you are used to factorizing, you could go ahead and look for the factors of 12 that sum to 4. And you can see this factorizes out to h plus 6 and h take 2 equals 0. So then the solutions are -6 and 2, as we found with this method up here. Okay, let's go ahead and do another example. So let's do g squared take 14g take 15 equals 0. Now you can factorize this quadratic, but we want to go ahead and try to use this new method. So first thing we say is the sum is the negative of the coefficient of g. So negative of -14 is just 14. Then we can say the solutions are half of this, so 7 plus u and 7 take u. Then we multiply them together, we get 49 take u squared, and this is equal to this constant here, this -15. Then go ahead and solve for u, so we add that 15 to 49, and we get u squared equal to 49 plus 15, that's 64. So u squared is 64, then u is equal to 8. And then plug that back into these expressions for the solution, and we get g equal to 7 plus 8, which is 15, and 7 take 8, which is -1. And then if you want to check this, you can go ahead and factorize this quadratic up here, and you'll see the factors of 15 that make -14 are -15 and +1. And so you'll get the same solutions if you factorize that quadratic. Alright, so hopefully this is starting to make sense. I want to do one more example where the coefficient is not an even number, so we'll actually get a fraction in this step here, but you'll see that that's totally fine and it still works out. So let's do another example down here, and we'll do c squared plus 7c take 60 equals 0. Again, this is another example that factorizes, and I'll do one that doesn't factorize after this. But let's have a go, and maybe you can have a go yourself at this, following this new or different method. So firstly, we say the sum is equal to the negative of the coefficient of c, so -7. Then we say the solutions are half of this. So half of -7 is -7 on 2, and I'm going to leave that as a fraction, but you could also use decimals as well. So -7 on 2 plus u and -7 on 2 take u. Then we want to go ahead and solve for u. So to do this, we multiply these together. So we'll have the square of 7 on 2, which is 49 on 4, take u squared equals -60. Then u squared will be 49 on 4 plus 60. So let's just write that out. And then to simplify this, you could multiply 60 by 4 or write this as a mixed number. I might just simplify it into one fraction. So 60 times 4 is 240. 240 plus 49 is 289 on 4. So 60 plus 49 on 4 is 289 on 4, and therefore u is going to be the square root of this. Now I guess you have to be quite good at your square numbers for some of these, but 289 is actually 17 squared. So if we take the square root of that, we'll get 17 on 2. And then if we go ahead and look at the expressions for the solutions, we will get the solutions for c. So -17 on 2 plus 17 on 2. You would get 10 on 2, and then 10 on 2 is 5, and -17 on 2 take 17 on 2, that's -24 on 2, which is -12. Okay, so there you go. There's an example where the coefficient is an odd number, so you can see it still works. It does get a bit more complicated with the fractions and sometimes quite large numbers that you need to take the square root of. And then if you want to factorize this, you might actually find that factorizing this expression may be easier than following this new method. So it's not the case that I'm saying, okay, just do this method and don't worry about factorizing anymore. It's more of the case of, well, add it to your tool set and maybe it comes in handy now and again when you can't factorize an expression. And also it's a method that will always work, which is nice as well. So it's kind of like an algorithm that you just follow the steps and there's no guess or check. So that's nice as well. All right, so let's do a few more examples. Let's look at an example where I think this is most useful in a case where you would typically have to use the quadratic formula. So we have x squared take 8x plus 13 equals 0. And this is not a quadratic you can factorize. There are no factors of 13 that'll make 8. So typically you'd have to pull out the quadratic formula and solve it that way. But we can still use this new method even for this example. So again, we say the sum equals 8 this time because we have a negative here. So when it's negative, we can just say the sum is positive 8. Then our solutions therefore become half of this plus u and take u. So 4 plus u, 4 take u. Then we can say, using the difference of two squares, we can say 4 squared take u squared equals the product, which is 13. And then, well, if we rearrange this, we would add u to the right hand side, take 13 from the left, we would have u squared equal to 3, and then u equals the square root of 3. Then our solutions become 4 plus u and 4 take u. So we have 4 plus root 3 and 4 take root 3. And they are the solutions to this quadratic. Now compare that to using the quadratic formula. I think this method actually is a shortcut to the quadratic formula. Okay, so now I want to look at an example where the coefficient of the squared term is not 1. So it still works in this case. We can still use that new method. So let's look at 15p squared plus 2p take 1 equals 0. So this actually factorizes, and if you were looking to factorize this, you'd be looking for factors of 15 that make 2. So this actually factorizes quite nicely. But let's go ahead and use this new method. And the first thing we have to do is to make sure that the coefficient of the squared term is 1. So we have to divide through by 15. So this becomes p squared plus 2 on 15p take 1 on 15 equals 0. And then therefore we can say the sum is the negative of the coefficient of p, which is negative 2 on 15. And then therefore we can say the solutions will be half of the sum. So half of 2 on 15 is 1 on 15 plus u, and negative 1 on 15 take u. So then using the difference of two squares, we can say that 1 on 225 take u squared equals the product. Now the product in this case is negative 1 on 15. And I should point out, when you're looking at the sum, you take the negative of the coefficient. When you're looking at the product, you just take whatever that constant is. So then if we continue with this equation down here, add the u squared to the right hand side, add the 1 on 15 to the left hand side, we would get u squared equal to 1 on 225 plus 1 on 15. And this is always going to be the case, by the way. You can see we always have the u squared equal to the constant take the constant on the right hand side. In this case, because it's a negative, we're adding them. Then if we were to simplify this, we would multiply this fraction by 15. 15 times 15 is 225. So then we'd get our common denominator. So to simplify, we would get 1 plus 15 on 225, which becomes 16 on 225. So that's what u squared is. So then therefore, we'd take the square root of that to get u, and we would get 4 on 15. Remember, we just did 15 times 15 to get 225. Therefore, the square root of 225 is 15. So we have the solution of u. And I should point out now that we're not doing the plus or minus u, because even if we wrote here plus or minus 4 on 15, we would still get the same solutions. It would just work out, you just have to do extra steps. So we can just say u equals 4 on 15. We don't have to add that plus or minus there. So we have the solution to u. Therefore, we can say the solutions are negative 1 on 15 plus u. So in this case, we would get negative 1 plus 4 is 3 on 15, which simplifies to 1 on 5. And then if we look at the other solution, we get negative 1 on 15 take 4 on 15. That simplifies to negative 5 on 15, which equals negative a third. So our solutions there are 1/5 and negative a third. And let's go back to the original one just to check. So if we were to factorize this, as I said, we'd look for factors of 15 that make 2. We would get 5p plus 1 and 3p take 1 equals 0. Sorry, that's the other way around. That should be negative 1 and plus 1. So then if we expanded this out, we get 15p squared plus 5p take 3p, which would be 2p, and then negative 1 on the end. Okay, so that was an example where even if the coefficient is not 1, you can still use this method to get to the solutions. So hopefully by now you're getting your head around how this works, hopefully. And you can also see that it's nice that even if you cannot factorize a quadratic, you can still follow this method. And actually, compared to the quadratic formula, you might say that it's more straightforward. But let's do one more example, and hopefully you can maybe do this one yourself. So maybe you can actually, you've got the hang of it already, and you'll be able to give it a go. So let's have a look at 4y squared take 20y plus 25 equals 0. So this is another example you can factorize, but give it a go. See if you can use this new method of solving quadratics to get to the solutions for this. So pause the video now if you want to have a go. All right. So the first thing we have to do is to divide through by 4 to make sure that coefficient is 1. So we would get y squared take 5y plus 25 on 4 equals 0. Next, we say that the sum is the negative of the coefficient of y, which is 5. So then our solutions become half of this, 5 on 2 plus u, and 5 on 2 take u. Then using the difference of two squares, we can say that 25 on 4 take u squared equals the product, which is 25 on 4. Okay, so now what happens? Well, this number is equal to this one, so therefore we would get u squared equal to 0. What does that mean? Well, u equals 0. That means we only have one solution to this quadratic. It is 5 on 2. So 5 on 2 plus 0 is the same as 5 on 2 take 0. So our solution then is 5 on 2. And if you were to factorize this quadratic up here, you would notice that the factors of 25 and the factors of 4 that make 20 are 2y and 5. So if you were to factorize this, you get 2y take 5 and 2y take 5. So we only have one solution, which is 5 on 2. All right, there you go. That is a new method to solve quadratic equations. I'm really curious as to what you think about it. Do you think you'll be using this in the future? I'm also curious as to what the exam boards would say if you pulled this out in an exam, because usually the mark schemes say you have to use the quadratic formula. So if you were to do this without the quadratic formula, I wonder if you'd still get the marks in an exam. Also, show your teacher. Maybe your teacher would be interested in seeing this new method, and maybe then they'd show the class, and maybe it makes more sense to some people. Right? Maybe you yourself are comfortable with factorizing and you don't need to make use of this new method, but maybe for some people, the fact that there's no guess and check and no trial and error, maybe that is somehow comforting to them. And maybe the fact that you just have to follow an algorithm maybe makes more sense. All right, I hope you found that useful. Please leave a like if you did, subscribe if you want to see more content, and I'll see you in the next one. Bye for now.